While the world scrolls past another headline about CERN putting the Large Hadron Collider into shutdown mode until 2030 for so-called routine upgrades, something deeper may be stirring underground. What if the real transformation isn't just about smashing more particles, but about feeding an entirely new class of AI with quantum-level insights that could dramatically outperform anything we have today? Set the stage clearly. Officially, the high-luminosity LHC upgrade will deliver up to 10 times more particle collisions, generating enormous new streams of data. The public story emphasizes scientific discovery, international collaboration, and even sustainability through more efficient operations. But beneath that green cloak sits a massive increase in raw quantum information, precise data on fundamental particle interactions, quantum fields, and high-energy behaviors that current AI systems have never had access to at this scale. Move into the core speculation. With this upgraded data fire hose, it becomes possible to train or refine AI models that are deeply informed by actual quantum physics rather than approximations. The result could be a supercharged AI that performs far beyond today's systems and even near-term quantum computers in key areas. It could simulate complex quantum systems with much higher fidelity, discover optimized solutions with dramatically less trial and error, and run tasks at speeds and efficiencies that make previous generations look primitive. Because the model better understands underlying physical constraints, it wastes far less computational effort, potentially cutting electricity and operational costs by 50%, and that's not to mention accomplishing complex tasks many times faster. Highlight the human stakes. A supercharged AI with this kind of quantum-informed performance edge raises serious questions. If access to these capabilities is concentrated among wealthy interests, governments, or closed research circles, the advantage becomes profound in the areas of modeling, prediction, biotechnology, finance, and autonomous systems. It's the kind of leap that worries the average hard-working John and Jane Doe. Because an AI operating at such a high level would easily outpace human oversight and decision-making within critical areas of employment. Okay, let's tie this together thematically. The multinational, open science framing of CERN provides a perfect environment for these advancements to develop quietly while the public narrative stays focused on green upgrades and fundamental physics. The collider shutdown isn't dramatic on the surface, but it quietly prepares the infrastructure that could hand a decisive edge to those positioned to use quantum-rich data for the next generation AI. No, what was said thus far is quite base-level details, but there's definitely more meat of deeper truth on this bone, and a lot that has much to do with this CERN shutdown period. Because from an honest perspective we don't know what they're trying to accomplish with this top-tier technology. Okay, you're reading that serves as the key of concerns the scientific community, not to mention the elites, don't want you knowing nothing about. Well, today that's not the case on MBM. Because this is a key topic matter you should look into deeper, and this is in regard to your welfare. So is there something sinister behind CERN? Well, let's just say there's a lot of things said about it over the last few decades, and I'm going over a number of them here and now, so without further ado let's dive in. No, there's claims by author and truth-seek researcher David Icke. He speaks out about the dangers that are shrouded in secrecy, and these are secrets that put every man, woman and child at risk. Okay, so where do we start? Well, the major aspect is the discovery of the Higgs boson, and how CERN helped researchers learn about the structure of space itself. Sounds mildly impressive. It doesn't take a rocket science to know that they do extensive research at the massive underground facility. It spans multiple surface sites and is packed with fascinating infrastructure, and CERN is also known as the European Organization for Nuclear Research. It's been in operation since 1954. And the experiments they conduct fall right within the category of risk takers. And the level of danger mentioned by critics range from the destructive force of black hole, to the alteration of time and reality. So hearing that alone brings up a vital question. What type of energy source are they using to conduct their experiments? No doubt that would be a mind-blasting fact to know. The obvious power source is generated by that super-duper Long Hadron Collider that stretches 27.3588 kilometers, or 17 miles long. The collider houses very powerful superconductor magnets, so one has to wonder how much the electric bill comes out to on a monthly basis if that's the case. But there was interesting input from David Icke. And he starts by pointing out the unprecedented energy levels generated that led to the discovery of the Higgs boson God particle, which was the result of the Large Hadron Collider, LHC. Started smashing protons together may reveal the hidden mechanics of how the universe functions. Icke starts off mentioning how the scientists working on this CERN project know more about this universe understanding than an overly curious researcher would about it. At the same time, scientists are not 100% informed about CERN's exact capabilities. Here's further details read by Icke. This, by the way, was from an article, and I'll post the link in the video. Just remember to pause the stream if you want to type that up and go visit the site to learn more. Right, he goes on to describe what you already heard toward the beginning of this video, the length of CERN's circular underground tunnel that spans 17 miles in length. CERN houses 145,000 miles of thick cable fiber within its constructed makeup. It shut down in 2018, which was around a 3.5-year period of inactivity, and operations picked back up in April of 2022. The reason for that was due to the installment of upgrades to increase the project's performance. Here's the eyebrow-raising thing about CERN. And that's the new experimental LHC, which is able to collect massive amounts of data while operating at a high capacity of voltage topping out at 13,600,000,000 electron volts, TeV. So the next scheduled run is said to be 2029, even though 2030 was mentioned but not fully confirmed. And the total cost sits at $9,200,000,000 for the inner workings within CERN's experiments. It features 2 activated beams of protons, basically particles of an atom, that travel in reversed directions at the speed of light around a ridiculously long extended 60-mile ring. What scientists and researchers are studying closely are the particle collisions that are heavily analyzed then, logged by scientists. Those 4 major sub-programs, ATLAS, CMS, ALICE, and LHCb, are actually giant, specialized cameras and sensors designed to record the debris of these subatomic car crashes. ATLAS and CMS are the 2 general-purpose giants that discovered the Higgs boson back in 2012, and they actively searched for signs of new physics, including hunting for the hypothetical particles that could explain dark matter. ALICE focuses on smashing heavy lead ions instead of protons to recreate quark-gluon plasma, a super-hot primordial soup that existed in the first microseconds after the Big Bang. Meanwhile, LHCb is a highly specialized detector looking closely at the differences between matter and antimatter to understand why our universe is made of physical stuff instead of just vanishing into pure energy at the beginning of time. Despite some of the wild sci-fi theories out there, CERN isn't actually creating dark matter or dark energy in a way that could threaten the planet. They're trying to observe individual subatomic particles that might be dark matter components to understand the invisible scaffolding of the universe. Because these experiments generate an absolute ocean of collision data every single second, CERN does rely heavily on cutting-edge computing, machine learning, and advanced algorithms just to sort through the noise and spot the rare patterns. However, their research is strictly confined to fundamental particle physics. They aren't working on building an autonomous or hyper-advanced super AI capable of breaking free or causing real-world danger. It's completely natural that people wonder what is going on down there. Given that the scale of the machinery looks like something straight out of a comic book or a sci-fi thriller, the reality is much more grounded in academic curiosity. It's an international effort to answer the most basic, fundamental questions about what the universe is made of at its tiniest levels, utilizing massive instruments to observe the building blocks of reality. If an organization like CERN were to completely shift its priorities or have its technology misused, the immediate risks wouldn't be sci-fi catastrophes like ripping open a black hole to another dimension or tearing the fabric of reality. The engineering of the Large Hadron Collider is bound by strict laws of physics. The high-energy collisions happen on a subatomic scale, meaning that even if something went completely wrong, the beam would simply lose focus, pierce its containment tube, and melt a section of the superconducting magnets, instantly shutting the machine down. The real-world danger of a compromised CERN wouldn't be a cosmic weapon, but rather the exploitation of its unparalleled, cutting-edge infrastructure. The true vulnerability lies in the immense computing power, advanced data grids, and specialized technological breakthroughs that CERN handles daily. If a malicious group or a rogue agenda took control, the high-performance computing networks could potentially be hijacked to train dangerous, unaligned dual-use AI models, optimize cyber warfare tools, or develop advanced cryptography, breaking software far away from public oversight. Another possible vulnerability is the specialized knowledge generated at CERN. This is regarding materials science, advanced magnets, and high-energy radiation could theoretically be classified and weaponized by a nation-state, could be used for a massive surveillance infrastructure. That's not to mention the tons of data that is managed there internally also poses a definite threat. Fortunately, the way CERN is fundamentally built makes a secretive or dangerous agenda shift incredibly difficult to pull off in the real world. It's run by a massive global coalition of over 20 member states, and its operations rely on thousands of independent scientists, universities, and researchers from all over the world who constantly monitor the data. Because every single experiment, line of code, and research paper is subject to intense international peer review and radical transparency, it is virtually impossible to hide a secret program or pivot the machinery toward an unethical purpose without the entire global scientific community immediately blowing the whistle. With that said, we have seen the impossible become possible, and it's no telling what the future brings us. People at CERN are managing unbelievable amounts of power, and in the wrong hands an unstoppable AI takeover isn't an impossibility. Hopefully that's not reality we'll ever see. Alright, thanks for tuning in, awesome viewers, and I'll see ya in the next session. So if you liked what you saw and heard today about this informative topic matter, then smash that like button. Make sure to subscribe to Mind Blast Mechanics, where we dive deep into the observations that matter. We'll get back to you as soon as possible. If you have a question to be answered, don't miss our next video, so make sure to tap that bell. Thanks for watching.